Good morning again. Here we go. So this is again year 10. It says lesson 1. It's not lesson 1. This is lesson 2. The year 10s get 3 hours a week if you are joining for the second time this morning. I'm not going to do one on Saturday and Sunday because we all deserve a break. But after the year 7 one I do on Monday, we will just do the third lesson and get through a few things. Right, so going off what we did yesterday, if we type in phonic, this is where we left off. So for those who are joining for the first time today, there's a video posted yesterday. I don't know, you can just look in videos. It's labelled year 10. And what we did is we learned how to create a random number, and then we created a random number using a range from something we had already set up. We printed that number, then we started to create a list. We added 3 items, all with string data type. We used a keyword called len to report back the amount of items in the list. This is useful if you've got a list which keeps adding. So for example, if you wanted to work for Xbox or something, every day millions are signing up to its Xbox Live service, it will append a username, their password and all of their credentials to a big database, and at the end of the day you might want to see just how many people are subscribed to your service, and that is needed so that you don't have to keep going in every day and changing the number manually. It will always count the list and return that number. We learn how to do some things with lists, like pop things out. Remember, pop removes the last item in the list unless you put a number in here, and then it'll remove the item at that index. We then appended something to the end of the list, and then we found a way of inserting something at a specific point in a list, and then that is where we left off. So the idea is we're going to create a hangman game, and we're not allowed to do any examples in these lessons which show you how to do it in hangman. I'm going to teach you all of the parts you need, and then you have to then in the end take every single concept we've talked about. So this is random, this is lists, and then we're about to go into the second parts today. And I think the best thing we can do today is a for loop. So like I said at the start of the program, put these 3 little dots, and then at the end of the program put these 3 little dots, and then you can still have everything we've done and like carry on creating new content here without having to run the old program. So what I think we do today is loops. So I think we should start with iterative loop. Now then, in computer science there's 3 major keywords you need to remember when you're programming. There's sequence, there's iteration, and then there's selection. These 3 words are extremely important because it's the whole basis of any running program. So sequence being your algorithm, the sequence of instructions you're going to program into the computer for it to follow. The iteration, does it need to repeat any part of it? Because every part of everything we do has at least some kind of iteration. Just keeping you alive right now has iteration in it. You breathe in, you breathe out, your heart beats, it pumps blood. That's it. It's an iterative process. And selection is like your actual thought process, to pick up the mouse, to move the mouse, to access things. You're selecting something for your body, some part of your body, to do a very specific task and using it to do something. It's the best way I can put it into like a human construct, but there you go. Right, so the thing we're going to look at is called an iterative loop, and we call them for loops. And for loops are very, very, very important, because there might be some point in a program where you have to do something a repeat amount of times, and it has to be done exactly the same way every single time. So an example would be, I just want the computer to print all of the numbers to 10. So rather than going print and then 1 and then print and then 2 or something like that, or even putting it like this, 2, 3, 4, 5, I want to print all of the numbers to 10. So we start with a keyword 4, and then we use what we call an iterative variable or a throwaway variable. We don't care about what this is called for now, so I'm going to say for count in the range of 10. So from 0, this starts at the number 0 in a for loop, and it goes all the way up to whatever you specify. So I'm just going to say in the range of 10. It knows it's a number. I'm going to print count. And you've got to see this work before you can start doing things with it. So if we run this now, it's just printed out all the numbers starting at 0, like we went over yesterday, to 9. There are 10 numbers here. So brilliant. What can you do with that? Well, this is now really important, because now we can start sort of do things with things which have like a sequence of things inside them. So if you take our list from above, so we'll copy our list, copy. This is why you do this, because now we can use our old code without having to remake it, and not only that, it gets you using it again and therefore getting in the practice. So if I've got subjects here, so for count in, and instead of putting range, let's put subjects. Let's see what happens now. Press F5 and look what it's done. It's printed everything in that list. Now then, that could be really good if you think about how could I use that data now. What if I did this in range len subjects, like I taught you yesterday, this keyword? What's it going to print now? It's going to print out 3. So we have got loads of things now we can do. If you've got that mind to sort of think forwards, like how can we use this? We can iterate through mass amounts of data in no time at all. So how can we make it a useful thing? Well, we can make like the world's we can make a game where it's for kids, and I think I've done this in lessons before. I think I always start with this. When I say I think, I mean I forget what I teach at the very start of the year, just to get people started with getting something working and showing them what the code looks like before I get into it. We are going to make a little game for kids where they can do their times tables. So if we go to what we did yesterday and we open our Google Docs, because if you remember what we did yesterday, if you watched yesterday's video, is I said when you're doing something you need to have some kind of file to document everything you're doing, and I said get a Google account, use the Google software, and yesterday lesson 1 Python programming, program a hangman game where they use the must have. So that's what we're doing, and then I built this in, and now I have done create a for loop. So that's what we've done, and then I'm going to say I go to an advanced section where I just do something with that information regardless of what I'm using. I just show you how it works in context, and I throw people forwards so they can see like a little bit of how you'd apply this, how you'd use it. This is for the people who didn't tune in yesterday. I'm just re-explaining stuff, making the video unnecessarily longer than it needs to be. So this is starting at 10 minutes 28. I'll put lesson 2 here. So that I know. So this is just for when all the videos are finished. I can just go back in and I can put these timestamps on the videos and make it easier for people when I say, look, this is how you do it. This is quicker, because there's no point redoing these videos over and over and over again. So we're going to make this game for kids. So I'm going to go for count. So for I, now this is a professional way of doing it. You use what we call a throwaway variable. I just call it a letter so that it's easier to remember. And we start with I, like, because if we were to do a nested loop, which we'll go into in another lesson, your next letter would be J and then K and then L, because sometimes you use X, Y and Z for simple numbers within programs just because you don't need them. If you're using a variable you want to use for the rest of your program, which you need to remember, naming them, things like that. I know putting an S on the end of everything, on the end of a word, is usually a list to me. When I'm making a list of things, I normally put G at the front because I know it's a range of things. But we'll get into that in another lesson when I talk about naming conventions. Right, so for I in range, I'm going to go 12 here. So we're making a really basic kids game, which they can get a sum printed to the screen and then they can check if it's right or not. So for I in range 12, print, and then we're going to go I, which will be 0, and then I'm going to go times, and then I'm going to comma, and then I'm going to go I, then I'm going to go comma, and I'm going to go equals, then I'm going to go comma, and then I'm going to do the sum or the product, because it's times, of I times I. And what this is going to do is print out all of the times tables to 12. So remember, it stops at 11. I need it to go to 12, so I'm going to put my range to 13. So if I run this now, like, we get that. So 0 times 0 is 0, 0 times 1 is 1, 0 times 2 is 2 times 2 is 4, 3 times 3 is 9, and you can see it's doing all of the square numbers because it's like that. But that's not what we want. We want to get the user to type in the number of times table they want to learn. So at the start of here, I'm going to type in number, num. Oh, I'm not using num because I'm already using it above, so I'll call it times table equals int, because it needs to be a number, input, enter your times table number. So when you've done that, it's going to go from 0 to 13, but this time we are going to print 0 times, and instead of this being I, we are going to use times table, and then it's going to be I times table, and then we run it, F5. So enter your times table number 7. Fine. What you should get is 0 times 7 is 7, 1 times 7, because I entered in 7 if you didn't see that. I'll make this a bit bigger. I'll try my best to keep everything into the center of the screen, just in case my little message at the bottom gets in the way. So 0 times 7 is 0, 1 times 7, 14, and we've just built a teach yourself times table. So that's how you probably use a for loop. Now we could extend this program now to when that's done that and you've entered and you've shown the use your times table, you could get rid of the for loop and just start picking out random numbers from a range of 0 to 12, timesing it by another random number of 0 to 12, printing that to the screen. In fact, I've just had a good idea actually. Every time I've done an advanced tutorial like this, I'm going to suggest something you can go and do, and maybe you could upload that and show me that you can do it. It'll just show me if anybody's actually watching the videos as well and having a go at something. So I'll put this in the PowerPoint now from now on. So it's an actually good idea that. So after the advanced now, we're going to go demo. We're going to call it a demo, and I'll write this out. So I'll make this available, this document, to everybody, so that they can just have a look at what we've done, because there might be loads of pages here. So the demo for this creating a for loop would be create a for loop which shows the whole of a user's timetable. I want you to do that first, but then I want you to print. Now this is not using a for loop, you see, but it's just getting you using the program, because what we could do is we could create a button, some graphics on the screen, and then you type in your times table, it shows it you, and it gives you 7 seconds or 10 seconds to look at it. The screen goes red, and then the next part of the program says what is 6 times 7, 5 times 7. You could get it to do that. So program a random generated times table question. Do it 5 times. So there we go, we are using a for loop. You've got to go for I is 0 and it's not greater than 5, or it's up to 5. Keep asking this randomly generated question. I'll put a star on that because I'm going to need to put a solution to the problem maybe in here so that you can have a look if you get stuck. But that's the point actually. I'm not going to ever show you a solution to that because that's your learning, I guess. Right, so that's for loops. Going to need them. Very, very important that you understand how they work, and you can do a few things with going into them, coming out of them, and using their numbers to do things a set amount of times. Like I said, that you're going to give the user 5 questions, and the only way you can repeat the same thing 5 times is to use a for loop. So in the for loop you generate a new random number, you then print out what is I times the number they typed in up here, and then if the I is equal to that sum, which you'll do behind the scenes, then print correct. We did that yesterday, I think, when we did the is your number this number. And there you go. That's actually quite a nice little task. That I might write that down and start doing a 5 a day. Because I saw on a website some maths guy does like a 5 a day programming tricks, and I think I'm going to start doing it because it's a really good idea. Really simple challenges. What can just get you started. Right. So let's have a look at what we're doing next. Because I wrote in a document. I wrote the program, and I broke it down and said, what can we do? Right, this is very similar, this next bit, to what we've been doing. We have to talk about how do we make things repeat forever. Now, we've already done it in one of our advanced sections, and this is what we call a definite or non-definite. I don't know if that's a word, but it's either definite or non-definite loop. Now this is similar to the for loop. We call them while loops. So this loop, the while loop, is different from a for loop, meaning we can either choose to go in it or not if you want. If you look at this line of code here, you can see it'll run that, and it has to go in there whether you like it or not. Hence why every single time it ran this. So I'm going to comment out this code, and we're going to talk about while loops. So the keyword obviously is while, and then another keyword we can use with them is this word called true. Now if you just type that and put a colon at the end, it will definitely jump into this loop. It's a definite loop at the minute because it has to go into it because while true, I'm going to print hello. And what you'll see when you run it is it'll just print hello forever. I don't know if you can see at the bottom of the screen, but if I just minimize this a bit and then scroll it up, if that's in the center of the screen, it's just continuously printing hello. You can see it's getting bigger and bigger and bigger because it's in a forever loop. It's just going to do that until, well, it'll just do this forever. So you're going to stop the program. So what we mean by a non-definite loop is if we can go into this loop if we want to, and we supply it with a condition while x is equal to 1. And I think you can put this in brackets if you want, just to make it easier for you to see. So while x is equal to 1, print hello. Now if I run it now, it should break the whole program because it doesn't know what x is. X has not been defined. So if I put x to equal 2, it's not going to go into this loop. Like, we're expecting it to say hello, otherwise we'll print outside of the loop. Notice that it's on the, it's flush against the side here. I'm going to print hot dogs, just so that you can see it's something stupid and you know that we've not been into here, because if we're going into here it's going to print hello, and if it's not gone into here it's going to print hot dogs. So we press, because it's got to jump over this. This is what we mean by it's a non-definite loop. So we printed hot dogs. If I change x to 1, it goes back into my loop again. So that's great. What if I want to come out of the loop in a while? What if I want to actually end? Normally this is the first thing you jump in when you're in a video game. Like, has the user press start? No. When they press start, they jump into the loop, and then when they get less than when their health goes below 0, it shows another screen, or if health is less than 0, it will go into this if, and then it will break out of the loop. So hello, and then we're going. I'm going to go count equals 0, and then sorry, yeah, so count equals 0. So when it jumps into this loop now, when I stop it, it's going to jump into this loop and print that hello, and then count is going to equal to 0. Oh, sorry, I put count here. Sorry, count equals 0. And then I want to, but every time I go around, I want to go plus equals 1 to count. So it'll start with 0 when it jumps in. It'll go here, then it'll start again, and then it'll go 1, then it'll go 2, then it'll go 3, then it'll go 4, then it'll go 5. If count is equal to 0, 100, so if it's printed hello 100 times, we are going to break, and then we are going to print hot dogs. So this is how you get out of a conditional loop. So if I press F5, it's going to do that, and then look, it's jumped out and printed hot dogs. Let's do that to 1000 so you can see it do it again. I don't know if you can see it because of the bottom of my screen, but if I press F5 now, it's waiting now to get to 1000. I know it's printed hot dogs now, and if I just put my thing into the center of the screen, you can see that it's probably printed 1000 hellos before it printed hot dogs. There you go. And then that's how you'd use a while loop. So this would be, we jump into a game and we have to keep doing the game, keep playing the game until you're dead, and that is going to form the basis of our advanced question. So let's go back to our thingy. So we have, I'm going to put this on a new slide now, so I'll copy this slide. I'm going to say creating a while loop. Delete all this, and our advanced example is going to start at 2511. And then remember, if we've got a demo coming as well. So our advanced example is simply going to be, we can only go into the loop if the user has pressed start. So we're going to go input equals, do press start to begin. I'm going to put 1 or 0 because I don't want to mess about, so we're going to put user equals int because it's a number. I just want a number. If they type in any letters, I want it to break. So while user is equal to 1, start the game. Otherwise, we're going to print game over, exiting. So that's when the user presses 1, it's going to start the game. Now we want to see if the health, so we're going to do another while inside this while. So we're going to set the health to 100. While health is, so health is equal to 100. We've got to set the variable first. So while health is greater than or equal to 0. So you've got to go greater or equal to 0, greater than 0. If you get to 0 health, you're dead. Come on. So while health is greater than 0, I am going to import time. Like I said, this is an advanced tutorial. I'm not explaining why I'm doing these new bits. This just pushes you on so you can see how you might use it in a proper setting without it being a dead trivial example. So while health is greater than 0, so while user equals 1, so while health is greater than 0, which it is because it's going to be set to 100 straight away, we are going to keep repeating time.sleep. I'm going to wait 1 second. No, we'll wait 5 seconds. Health minus equals 25. And then when obviously this gets to 0 exactly, so in 4 ticks, it's going to come out of this while. I'm going to print you are dead. And then at this point I want to break out of the while loop and the game is just going to end. There you go. So press start to begin, or you can't see. I wonder if putting my things up here would be better, because I've moved them from up there because I wanted people to see when I was clicking on tabs and things so that they could see I was in something else. So I think I'll keep it like that from now on. So it's asking me to please enter 1 or 0. So type in 1 and then it's going to wait for 5 seconds and it's going to hopefully print out. Oh no, I've not got it to print out your health, so I'm going to stop the game. I'm going to stop the game and I'm going to make sure I know what's going on. So while user is equal to 1, so I've typed in 1, health is equal to 0. So while health is greater than 0, time minus 25, I'm going to print out health. I'm going to print health at the very start of the loop so that I know it's gone down. So it should say 100 to begin with, and then it's going to go and then it's going to go down 25 steps. I hope this works. So type in 1, so it's printed out 100, and in 5 seconds it should print out 75, and there it is, and then 50. Yeah. So imagine you're playing a game like Doom and you are standing on acid. Your energy is going to deplete, and then you are dead. So it's printed that, it's done the break, and now it's exiting the game. We might not want that. We might want to ask if the user wants to play again. So when you come out of here, you might want to, instead of exiting the loop, you could probably add this in. Do you want to play again? So input, so choice equals input. Or if you notice how I program, I write the construct out first like this. I do that, and then I write, do you want to continue? Now there's a reason why I do this, because I can choose my variable now. I might already have something I can use, so I check my program before I do it, but I know I don't, so I'm going to call it choice, and then choice equals input, do you want to continue? And then if you remember yesterday, I used this thing called dot lower, because they might type in a capital letter, but I'm going to put YN like this to guide them. If choice is equal to if choice is equal to Y, I am going to set health equals 100. I'm going to set my health back to 100 so that the game starts again. Else they didn't press Y, they pressed anything else other than Y. I'm just going to break straight out and exit in game. I think this will work. So there you go. Do you want to begin? One, bang. Sets my health to 100. We've got to wait 20 seconds now, but we'll do it because this is what I hate in lessons as well. Kids just doing this and then waiting these 5 seconds. Why don't you just set it to, don't even have the sleeping while you're testing. Just get it to bash the numbers out without waiting. But I'm just showing you like an advanced thing you can use to make again. Do you want to continue? Yes, we do. Set my health to 100. It will then set health to 100 again at the top. But it will repeat forever now, and we'll just waste our lives and wait for this 40 seconds of our lives just to slowly kill us inside, and then we'll press N and show you that the whole program works. And there you go, exiting game. So we're covering a lot of ground now. We've actually got enough, I think, right now to build this hangman game, but because I've got I'm only on 32 minutes, and I want to keep these lessons close to an hour, so that if you watch them back at the same time, it will take you an hour to listen and do. So my demo example for you on this is to my demo using a while loop will be to choose your options. Like if you were in year 9 now again and you were building a computer system for the school, you need to check that the kid has definitely put 3 items, appended 3 items into a list. So there's going to be an empty list, so create an empty list. And then you have to tell a student to enter 3 options. Only when 3 options are entered into the list can the program exit. So that will be like, imagine if we did it as a computer system. We got everybody in the school to sit at a computer, and you opened our little program here, and it says in the next screen you will see all of your subjects as buttons on the screen. You had to click 3 buttons. So when you click the 3 options you're going to do, the program checks whether there's 3 actual options against your name. So I get them to enter their name and store their options. This is printed at the end. So when you come out of the loop, so there's 2 loops you need to run it. You need to first of all put it into a while loop, getting them to continually ask to enter their subjects. So they're going to type in the subjects, and when they've got 3, it's going to come out of that while loop and then print the options they've chosen or they typed in, and then exit the program. That's what you're doing for your advanced example. So let's have a look at the time. We are on 35 minutes. this one can be pretty quick, I guess. So we are going to create user input, and then the advanced is going to come pretty sharpish with this. So I have looked at everything in this program, and now we're going to do something which you've already done 1,000 times, but I just want to show you a couple of other things we can do with it. So this was our while. If you take your 3 dots out, Control and X, and then Control and V, we can now just comment out everything we've done and start again. We're talking about user input. Now, you've seen and you've been using this all the way since the very start of these examples. So what I want to show you is data types. In programming, there are 5 data types. We've got the integer. Now I think I did this with the year 9s the other day, so if the year 9s are watching this, they'll have had a lesson on this and they'll know what's coming next. Integer is a whole number. It's any whole number, so 1, 5, 8, 100. That is a whole, oh, not with a letter in it, it's not. That's a whole number. Then we've got a float, which is equal to a number with a decimal point, and then that is 5.76, 99 point that, point, not a comma, that, and then point that. As long as your number doesn't start with a 0, it's a real number. So it's any number with a floating point. Then you've got what we call a string, and a string is anything in Python which is a list of letters, because what we call strings in programming is an array of characters. An array being like a list, like I explained in yesterday's lesson. It's just an array of characters. You can even, if I keep this into programming, if I print and I go string and I go 6 and I run it, it's printed out S because this is 0, 1, 2, 3, 4, 5, 6. It's printed out the 6th item in the list starting from 0. And that a string is basically just anything in Python between speech marks. So I'll comment that out. The other one is a Boolean. Now these are really powerful, these, and it can be true or false. Now I was trying to do something with the year. It's 1 or 2 values, only 2 values. Trying to do something with as an example, but I couldn't set the data type as a bool, so I'm going to have a look into that. I said I would and I didn't. So we've got integer, float, string, boolean, and there's a data type which Python doesn't have, which is a character or the char, and it's 1 letter. And then that could be that. But you don't just put it in that. You've got, when I'm using a character in Python, I use the singular quotation, because Python doesn't actually have a specific data type for a singular character. The reason you have these is when you're programming a real game, you've got to be really careful about how much data things are taking up, because when you've got millions of variables, and especially if you're creating them dynamically, your program could, like, in a game, how many variables do you think there are? There could be millions of them, or tens of thousands of them at least, and each one takes up a little bit of memory. And if you know you've only got so much memory to work with, defining exactly how big the data should be in this part on memory is really important. So you can do this, you can use this now when you're doing your programs. So if you know you're doing the last example, for example, the demo task from the last example, so I'll probably end up showing you something you can do for your demo task now. If you know you need to take a string, you can do this. You need a name of somebody, equals str, and then input, string input. See, I should do this the way I normally do it because I'm an idiot. I write input because that's what I need to do, and then I want it to be in a definite string, and I just build it like that first. Then I put in my speech marks, and then I enter the question, enter your name. So you can set a very specific data type. I can't enter anything else in now if I don't enter an actual string in. So I'll show you what I mean by this. If I enter in 45, well, that can be seen as a number. If I press enter, it shouldn't work. So, but Python might again let me down and work. Oh, it probably has converted it to a string, but I know if you do this one now, so we're going to do money. So how much money do you have on you right now? I'm going to write float. I'm going to write input, and then enter your money. So if you enter, whoops, if I do this now, I'm going to enter your name, so RHO, enter your money. If I type this in now, DF, it should break out like this, because you're not allowed to convert a string to, oh, that's why it does that, because you can convert a number to an actual string. You can, this is why typing in numbers is a bit weird, because before we were doing this, my name, because I've got to use a different variable, equals input. This is almost the same as doing the thing below, enter second name. So you could put surname here actually. Can you see we've been using this so far, and it just converts whatever it gets to a character. I've got to find out what the conditions are for a string now in Python. So float, enter money. If you enter in, so that's my name, and if I enter in 67, what that'll do is it'll convert it to a 67.0, because in some programming languages, if you specify it as an integer, it'll cut off the actual decimal point. So enter your money, 56.98, and that's done. And then we've got your age, which is an integer. Input, enter your age, and then we've got the bool at the end, but I've no idea how to make this quit or say something different, so I'm just going to say is amazing equals, and then I'm just going to have this as an input, because the only answer you can have for this is going to be yes or no, or true or false. And that is getting user input. As long as you use this input keyword, that's how you get it. But what you know now is you can specify specifically what the user's getting. So advanced example for this would be it's coming at 44.18 perfect. 44.30 it'll be by the time I type this and got back into funny. So our advanced example will be a game we've made in lessons before, which is we are going to, I don't want to keep printing that out every time I do this, so I'm just going to comment that out right now. We're going to get the computer to pick a random number. Remember, this is an advanced topic. I'm not explaining this new line I've just put in. I'll tell you what it does, but I'm not going to explain it any more than I don't have to type the word random in anymore. So I'm going to go R&D equals ran range 10. I'm going to go while true. If you haven't done the other lessons, you won't know what that's doing. A equals int input. I'm having to use an int because it needs to be a number. What I'm about to do, enter a guess. If guess is if A is greater than R and D, print too high. Else elif A is less than R and D, print too low. Otherwise, print you got it. So let me explain the advanced tutorial to do with user input. If you don't specify this as being a number, then this program can't work, because how is it going to know if letters are above or below an actual number? So when we run it, it's going to say enter a guess. 5, the guess is too high. 4, it's too high. 3, you got it in 3 goes. But what if, because it's only out of 10, we only give him 2 guesses? So guess equals 2, while guess is greater than 0. So every time you enter a guess, we are going to go guess minus equals 1. Come out of the loop. Game over. It took no, we're not going to bother counting the guesses. Make it quick. Enter a guess. We've got 5. It's too low. 7. Enter a guess. So print. You have a guess. There you go. So now we've got a little program going where you have 2 guesses left. Enter a guess. We're going to go 5. You have 1 guess left. It's too high, so I'm going to pick 3, and that was too high. Game over. We've obviously only have two tries to guess a number. If we put the guesses to 5, let's see if it works. You have 5 guesses left. Enter guess 5. It's 4 guesses left. It's too low, so 6. It's too low, 7. Too low, 8. Yeah, we got it at 8. It took us 4 guesses. Well, there you go. That's your advanced example of where you should always try to define your data type you want in, because it's really important that you don't get users entering in things they don't want. Your demo example for this, and this is going to be it for this video, because I do want you to try and follow it along at the same time. It's 10 minutes shorter than an hour, so the pausing and doing might fill in that time. But you really have to apply yourself when you're doing programming. There's no easy way around doing it. So your advanced topic for using user input would be create a program which asks the user for a name. If they type one non-letter character within that name, it will repeat forever until they do. Now there's some things you have to do some research on here. I'll give you a clue. You have to use a string manipulator like is alpha or is, I think that's what it's called actually in Python, is alpha. You have to use that to check your string. You might have to use a for loop, unless is alpha is the for loop and it's just a little function within Python what does it for you. But you're going to use a while loop to jump in, and it's going to keep checking forever if this string you have typed in is all alphanumeric characters. And as a bonus, if you can say you have and then pick out the non-alphanumeric character, you have a thingy, whatever, a 4 in your name, please remove it. If you can do that, yeah, you're on your way if you can bring a program like that. I think I've left the comments open on this video because I want you to actually post in responses to some of these examples if you're watching this and you're not part of my classes while we're in these homeschooling sections. I'd just like to see what you come up with, because it's interesting to see how kids and students and people who've never done this before how they go around doing it, because when I show you like it can be done in maybe 1 or 2 lines, it develops that learning process and you become really good then, and then we start writing some really clever and advanced programs. I remember a lad who I taught, I think it was about maybe 5 years ago now. Is it 5? 1, 2, it might have been 3 years ago, 4 years ago. He'll probably know what I'm talking about if he joined, if he's watching this video, because I made them all subscribe to this when I was in my last school. He showed me a really nice way of doing a rock paper scissors using tuple lists. Now I've not done tuple lists yet with you, but I thought it was really good what he did. It was a really clean way of doing it, and I was using this weird list comprehension thing, which I thought it was too clever for its own good. And then this guy just showed me this nice, easy. It was brilliant. I've got to say, so I've used it ever since. Very clever, and I just hope for things like that every time I'm teaching, like just looking at you develop what you've got. You've taken like a small trivial example from what I've been showing you, and then you develop it into something really nice. Whether I've shown it you or not, or I've seen it before or not, you did it and you came up with that, and yeah, that's why I really enjoy the career. So thanks for listening, thanks for watching. If you want to use or learn any of the other topics, I mean year 7 or not, just give them a watch. If you don't understand some of the topics we've done, please use this video to comment, I guess. But this is strictly for my year 10s who need that little bit of back and forth dialogue. But if you know who I am, I can communicate through your email and Google Classroom. I'm not going to send a response through Show My Homework for this video. I will only send a homework request every Thursday morning with all the links to everything I've done. So the 2 videos I'll do will go in the Mondays, actually, because I do the 3rd lesson on Monday for year 10. But yeah, thanks for watching, and just give some of this programming a go, because when we start getting onto the putting graphics to the screen, it's all going to be pretty nice what we've got, and we can start building some small apps which you'll be dead proud of. So thanks a lot.